Let's raise the power. So we go from our linear function, we'll go to the quadratic function where the highest power is 2. So our quadratic polynomial and the parabola, which of course is the shape of the quadratic function. Some definitions. There's subtle differences between these things. The quadratic polynomial, what is that? It's an algebraic expression in that sort of form. ax squared plus bx plus c. Notice it's not equals anything. It's just a polynomial. The quadratic function then is when we make it equal to a dependent variable. So y equals ax squared plus bx plus c is the quadratic function as opposed to the quadratic polynomial. And then of course there's another type of quadratic we see. It's a quadratic equation, and that's when we make the polynomial equal to a number. More often than not we see it equaling 0. Now, ax squared plus bx plus c equals 0, a quadratic equation. If that coefficient of x squared happens to be 1, we call it monic. Coefficients. Well, just for the sake of definition, a, b and c are the coefficients. Indeterminate. Indeterminate, you hardly ever hear the phrase used anymore, but it's actually the x value. It's another name for the x value, indeterminate. Now comes a very subtle difference again. Roots. Roots are solutions to the quadratic equation, as opposed to zeros. As opposed to zeros, which are the x-intercepts of the quadratic function. Yes, they have the same value, because how would you find the x-intercepts of the quadratic function? You would solve the quadratic equation, but technically we talk about roots of an equation and zeros of a function. Here it would be more correct to say find the roots of x squared minus 1 equals 0. We wouldn't say find the zeros of it. Find the roots. And what the heck, let's go and solve it. Very tricky. X squared equals 1. Oh, what do you know? X is plus or minus 1. So graphing it, we know it's going to be a parabola. There's our general one, ax squared plus bx plus c. Remember I was saying, just looking at it tells us a lot. There's a lot of information from just that equation. A, the coefficient of x squared. That tells me about the concavity of the curve. So that one I've drawn there, of course, has a is greater than 0. Has a positive concavity. It's positive, it's happy, it's smiling. Concave up. That one there is concave down. It's negative, it's feeling down. Concave down. A is less than 0. B I'll skip for now, but C, just like the linear function, in fact for all polynomials, the constant will always be the y-intercept. Has to be, it's what you get when you substitute in x equals 0. You get the constant value. The zeros or the roots, depending if we're talking about the function or the equation, but they are, as we say, the x-intercepts basically. I said B by itself doesn't really tell us a lot. But when we put it in this form, minus b on 2a tells us a lot. That is our axis of symmetry. That's the middle of our quadratic. Now, how do I know that? Think back to the quadratic formula. Minus b on 2a plus or minus. So minus b on 2a must be the central point, the axis of symmetry. Another way of finding it, if I've already worked out what the zeros or the roots are, then I can just average those because of the symmetry. It's always going to be in the middle of those. Vertex then. Well, once we know that, we can sub it in and then we get the y value. We've then got the vertex. And the vertex, of course, is quite important if we're solving problems with quadratics, because we know it's going to be the maximum or the minimum value depending on whether it's concave up or concave down. Let's graph this way then. X squared plus 8x plus 12. Yeah, look, I wouldn't write this down normally, but I'm drawing the information out. A equals 1, so it's greater than 0. I know it's concave up. C is 12. Well, I'll plot that in. There's the y-intercept, 0, 12. What are the zeros? Let's find those x-intercepts. Solved in the quadratic, I get negative 6 and negative 2. Let's plot those in. It's starting to take shape. Axis of symmetry. Yeah, I could use minus b on 2a. I come up with the answer negative 4, or I could average those two solutions I just found. Again, I come up with minus 4. No, I would not draw the axis of symmetry in normally. I'm just using it as illustration for the example, but there is the axis of symmetry of the shape I will draw in. I need one more piece of information, don't I? The vertex. I still need the y value. Let's sub in. There it is. Oh, by coincidence, it's also negative 4. Now let's plot that in. Now I've got enough information to draw a sketch, so let's draw it. There's our our parabola. Say I only know some pieces of information and I want to pull it together into an actual function itself. So which quadratic would have the roots 3 and 6? So if they've got the roots 3 and 6, then I know it must be that. Why? Well, remember, we usually say what multiplies together to give the last number. So that last number must be the two roots multiplied together. 6 times 3 gives me 18. The middle one, though, we have to be careful with. Whilst we normally say what adds together to give the middle number, but remember, these are the solutions. When we factorise this one, I would get x minus 6, x minus 3. So the roots are actually 6 and 3, but the middle term will be the negative of that because we're solving the equation. So you've got to be careful. The middle one, it'll be the negative of those roots. You'll notice I put an A out the front there because without more information, I don't know the concavity of the curve. Maybe it's monic, maybe it's not. But this time they've told me it is monic. And it has roots 3 plus root 2, 3 minus root 2. But I can still use the same idea. The solutions will always be conjugates. So in this case, 3 plus root 2, 3 minus root 2. Nice thing about conjugates, when I multiply them together, difference of two squares, I get a nice number. In this case, 7. And when I add them together, the irrational part is going to cancel. So I get 3 plus 3 is 6. So we get x squared minus 6 plus 7. This time I've been told the two roots and the vertex. So again, I don't know the concavity of it yet, but I do know they multiply together to give 16, they add together to give 10, so it must be minus 10x. They've given me extra information. It goes through the 0.53. Well, I'll substitute that in. Solve that. A is minus a third. There's my equation. All right. That shall do us. With question 4 in the exercise, you might want to use Desmos or another graphing package if you've got one you prefer, GeoGebra or some of the other ones that are out there. But you might find that useful for question 4 there.